The Lewis definition is going to be broader than the Bronsted and the Arrhenius definitions, and we can definitely make an Arrhenius or Bronsted acid or base look like a Lewis acid or base, but not the other way around. The big advantage here with the Lewis acid base is it's going to explain non-aqueous reactions. We kind of get spoiled because we work with water so much, and water produces H plus and OH minus, but let's say you're working with something like ethanol or pyridine or tetrahydrofuran. These are compounds that don't necessarily form H plus in solution, but they still look like acids and bases. So how do we explain acid-base chemistry when we step out of water? And this is where our Lewis definition is going to step in. Now, this is going to be very radically different than the Arrhenius and Bronsted definitions. For us to have a Lewis acid, our acid here has to be what's called a lone pair acceptor, and our base is a lone pair donor. So this is going to harken back to our Lewis structures and our Lewis theory. What happens between an acid and base is that they form a bond, and they form a bond by exchanging electrons. The base in this case is going to take its two lone pair electrons and use it to form a bond with A. A is going to accept, our acid is going to accept these two electrons to make a bond. So the bond comes purely from the base. How do we backtrack this back to our Arrhenius and Bronsted definitions? Well, we got H plus, and we've got OH minus, but we're actually going to write it out. So H minus here is our quintessential example of a base. H plus is our quintessential example of an acid. The way H plus and OH minus act like acids and bases is that the hydroxide will donate its lone pairs to the H plus, and this will give us our water. So this is the acid-base behavior of water, and it explains where it comes from in terms of a Lewis structure. So, a few comments. First of all, the definition is going to be backwards from a Bronsted. The Bronsted, a donor is the acid. In this case, the donor is the base, and it's also going to differ in terms of what's being donated. With the Bronsted definition, you're donating in a proton, whereas in the Lewis definition, you're donating a lone pair. The goal of the Lewis here is to create bonds and explain where the bonds come from. Now again, we can take any Arrhenius acid base, any Bronsted acid base, and make it look like a Lewis acid base, but not the reverse way. Again, the big point here is to pull us out of aqueous, to let us look at how bond breaking and bond making functions in terms of acid-base behavior, and kind of give us the ability to work with solutions where there isn't necessarily H plus or OH minus available because of the solvent.